Let's pray. Father in heaven, we thank you and we this time that you've given us. We thank you as candidates of the year 2026, especially the mathematics class, that we are here not as individuals but as a nation. I pray that may you guide us, may you guide our facilitators, open our minds so that we shall be able to understand, comprehend, and be able to understand the scenarios. And Father, when we come out successful, when we gain something good from, we shall always glorify your name and confess that you are God. We pray through Jesus Christ our Lord.
Amen. Thank you so much for the word of prayer. Allow me now to start off with our discussion right away. I do hope that each one of you on the call, you have already received the seminar questions that we are going to discuss. My name is Kasva Stephen, and I'm going to be the one to take you through our discussion today. I'm sharing my screen. Okay. I'm sharing my screen. Okay. Our focus today, we are going to focus on paper 1, and then next week we shall handle paper 1. Today we are focusing on paper 2, and next week we shall handle paper 2. Dear students, as you approach this paper, one of the things I want you to do is that you need to plan. Whenever you receive your paper, first plan. Whenever you get this math paper, first check out what number is going to be easy for me, which number is much doable. So always, I want to encourage you, start with the number you are well conversant with, the number you feel you are going to get the maximum mark. Number 2, communicate. Communicate means that tell the person looking at your paper, what are you working on? What are you calculating? What are you finding? Don't just calculate things without communicating. So communication here, we are looking at what are you calculating? That I'm finding the area of this, that I'm calculating the number of tens, that I'm calculating the area using the trapezium rule, that I'm calculating maybe the frequency, that I'm calculating this and this. So for whatever thing you are doing, make sure that you communicate. You tell us what are you working on. Then what we call organization. By organization, we want that when you are presenting your work, let it flow coherently. Let your work flow very well in a very vertical format. Don't just do things when your work is not flowing. And always use the best handwriting possible whenever you are presenting your work. But also, I want you always to critically think before you respond to those different items. Do not just answer, but make sure that you critically think. Now, which approach are we going to use when we are working on the different scenarios? I want you that always identify the concept. Concept identification is very key. Before you start working on this scenario, ask yourself what concept is embedded within this scenario. Then check out which method is the best, is the suitable method for me to apply for this particular scenario. Then ensure that the output, the answer you are getting is very accurate. When you are getting decimal points, please check out. If it's not angles, have I written my answer to at least 4 decimal places? In case it is I'm working with angles, at least have I written my answers to 2 decimal places? If this particular answer I'm still using it, am I leaving my answer in thirds? Have I written to quite a number of decimal places such that you are very accurate? Then ensure that you interpret and you make a decision. Some of these items, they are going to require you to compare different things. So always interpret and make a good decision. Sometimes they may ask you to advise, sometimes they may ask you to recommend. So you do basing on what result you have obtained from that particular scenario. Now, when you look at our seminar questions, we started with the numerical analysis, and that is what we are going to look at. And when you look at numerical analysis, you'll find things concerning trapezium rule, iterative methods, flow charts, you are going to find a bit of errors in there, or you will find errors, but errors can cut across different papers. It can be in paper 1, it can as well be in paper 2. They can ask you to calculate maybe percentage error in paper 1. They may ask you to calculate percentage error in paper 2 when you are dealing with calculus. So what was our item? When you look at my screen, this was our first item that we dealt with, and it was telling us that the Ministry of Fisheries and Aquatic Resources, the Ministry of Fisheries and Aquatic Resources plans to establish the Ministry of Fisheries and Aquatic Resources plans to establish a commercial fish farming project in a natural water body. But before approving this project, they measured the depth of water body at equal intervals across the proposed site. Now, dear students, whenever you read the scenario, I want you to relate it to real life. Ask yourself, how is this related to real life? Now, the moment you start relating, visually see, draw those mind maps on how it can look like. Then it will be easier for you to approach this particular scenario. And what do they want you? They are telling us that the engineering department has recommended the site for commercial fish farming on a condition that the estimated cross-section area of the body is at least 62.85. Now, whenever you receive these items, I want you always to go on and highlight the mathematics within the scenario. What is the mathematics that they have told me? I estimate the cross-sectional area of at least 62.85 meters squared. And now that is the condition. Now, when you look at these scenarios, you'll find that paragraphs are going to be corresponding to the task. More so if the tasks are more than one, like when you find part A, part B. Whenever you find the first paragraph, you'll find that it corresponds to the first part A. Unless when it is a block question or a block task that requires you now to interpret everything you have within the scenario. Now, after highlighting the mathematics, ask yourself, which concept is this? Which concept are they asking? Now, dear students, whenever you're approaching paper 2 mainly use what you call approximation methods. Whenever they talk about area, you need to ask yourself, which kind of topic talks about area? Which kind of approximation method am I going to use to find the area of irregular shapes? Now, when you look at my screen, now I'm trying to draw closer to how it can look like in real life. When you look at my screen, this is the source of River Nile in Jinja. So many times in math, when you want to estimate the area of such a water body, you cannot use the actual method, but here we use the approximation method. You may be wanting to come and estimate how the area that is occupied when you look at this lake. You may want to estimate the area. Now, the best way to estimate this area is using numerical approaches. Now, you need to know whenever they give you an irregular shape and they want you to approximate, and they have not given you a function, then you need to know that the best approach to use is an approximation method. Now, dear students, they can ask you to estimate the area of different things. It can be water, it can be land, it can be irregular fields, it can be curved surfaces, it can be things concerning economics, it can be coastal, they can be curves, they can be dams. Whatever I have showed you here, it can be asked. They can ask you to estimate its area. But how do you estimate areas for such? Now, that is what you looked at under the trapezium rule. So you looked at trapezium rule, and the trapezium rule is the one that we are going to use for us to be able to get. And when you look at my screen, I'm showing you what happens in real life. Before you establish a pond, before you establish fish farming, you need to know what is the depth of water. When you look at my screen, this is one of the fish ponds in one of the lakes. But before you put there the fish, the fish, you need to know the area, you need to know the depth, such that you know that this amount of water will favor the fish. This amount of water, this kind of area will be able to accommodate this kind of fish in there. Now, what is the evidence? Now, from the scenario, one of the evidence that you can look at is they told that 5-meter intervals. They mentioned something concerning meter intervals. Now, identify what clue have they given you in the scenario that they have mentioned things concerning equal intervals. Then now you ask yourself, what concept am I going to identify? Now, the concept is approximate integration. You know that when you are dealing with integration deals with summing up things. Whenever you want to sum up small things, it means that you are integrating. Whenever you eat food at lunchtime, you are breaking the food into small what? Into small particles. That's differentiation. Now, when the food comes into the stomach, things are going to start adding up such that you get the energy. Then that means that you are integrating. So integrating means summing up something to get a bigger thing. Now, that means that for this particular topic, we are going to add up the areas for the different shapes to A. And now, which method am I going to use? I'm going to use the trapezium rule. Now, once you know those things, then it means that now you're going to approach the scenario very well. Now, when you look at the scenario, we have identified what evidence they require. The evidence that is required is to find out, is the cross-section area of this water body at least 62.85? If now our calculation confirms that, then it means that we are on the right track, or that the minister or that the ministry should go on and maybe go in for it. But as we start now, our trapezium rule, now that we have identified that this is trapezium rule, because that's what we can use to approximate areas of irregular shapes. Now, what do I want you to remind you? That whenever it comes to estimating areas, please, dear students, just take it that now that one I'm applying estimating area. That is trapezium rule. Even if they have not specified for you, at the moment you see that I'm estimating area, I'm in paper 2, the shape is irregular, then that means, and even there are some functions that are not easy to integrate the way they are. Now, for such methods, whenever we are using an approximation method, it means that now we are using the trapezium rule. Now here in the question, I want you always to stick to the language used in the scenario. In the scenario, they use to estimate its cross-sectional area. Now we know very well from our trapezium rule, if I'm to remind you, that in trapezium rule, we have what we call ordinates. Let me come here. We have what we call ordinates. Now, when we talk about ordinates are the x values. When you look at our lake here, this one, it can be my starting point 0. And let me say A is my starting point and B is my ending point. Now, when we talk about ordinates mean this x value, like this point here. This is the first ordinate, second here, third, fourth, fifth, sixth, and then the 7th. Now, that means that those are 7 ordinates. When we talk about sub-intervals, or sometimes we call them strips, strips are the number of trapezia that you are able to form. So inside here, when you look at our trapezium, this is 1, this is 2, this is 3, this is 4, this is 5, and this is 6. That means that the number of trapeziums we can be able to form from here, there are 6 trapezium. But the ordinates are the x values. It means that for them we have 7 of them. Now, when we are to estimate, we shall say now cross-section area. Remember the scenario, use the word cross-section area. Are you seeing from the scenario, cross-section area of the water body? So I'm going to come and say cross-section area of the water body. And now here, specify which method are you using. I'm going to say using the trapezium rule. So I'm going to say now, since it is an approximation method, never use equals. Use your approximation signs. And what are we going to do? You know very well from your trapezium rule that we shall have h divided by 2, whereby h is the width, is the strip width, is this width of the trapezium into y naught plus yn plus, this is 2 into y1 plus y2 plus up to yn minus 1, everything crossed. Now, whenever you are dealing with this paper, feel free to come and now say that from here, what is my h? From here up to here is what we call your h. Your h is the width. So for this case, our h is 5 meters. Now, when I talk about y naught yn, y naught yn is like the height of the trapezium. When you look at this one and I'm to approximate it, you know that I can form a trapezium here, I can form another trapezium here, I can form a 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 trapezium like that. So now here we shall say that this is approximately h is the width, which is 5 out of 2 into y naught. Now when you look at our starting point, the height is 0. So we shall have 0 plus yn, which is the last, or here the last point, which is also 0, plus 2 into y1. When you look at our first height of the trapezium is 2.12. The next one is 2.94. The next one is 3.03. The next one is 2.77. The next one is 1.91. So now from there, we shall say that 5 out of 2 will give us our 2.5 into, this is 2. When you add everything you have in there, that is 12.77. And now this is going to be approximately 2.5 times 2, then times 12.77. And this one is going to be approximately, when you place your calculator, it will be 2.5 times 2 times 12.77, which is approximately 63.85. Now look at the units, that this is area, which is meters squared. So I'll come and say this is meters squared. Now, after obtaining your answer, go back to the item, go back to the scenario and ask yourself, have I attained the requirements? So you go back to the scenario and ask yourself, what am I supposed to find? That they're asking you to, on the condition that the estimated cross-section area of the wood is at least 62.85. When we use the word at least, it means greater than or equal to 62.85. Now you must communicate, you must respond. So now you need now to write your response. In your response, you tell us what is your conclusion and what is the decision you are taking within that. Now, when you look at our area, we have got, our area is 63.85. Now you compare it to what has been given. And now here we shall say that since the area, the estimate, and use the right words, the estimated area for the cross-sectional, for the water body is 63.85, which is above the 62.85. Therefore, it fulfills the what? The condition for the water body. Now, what should the minister do? So, because remember, you need to make a recommend, has recommended the site. So that means that the engineering department recommendation is what? Is correct. So the minimum area has been fulfilled, and therefore the ministry should go on to carry on the what? The project. That is how you deal with that. Next time they may ask you, how can we reduce? How can we make our area very accurate? Now you need to know that if we are to make the area very accurate, I want you always to reason basing. Do not come with the notes book, the notes knowledge, because they may ask you, how can we improve on the accuracy? Then now I don't want you to come and say by increasing the number of sub-intervals, by increasing the ordinates. No, look at the scenario and ask yourself, from the scenario, what are the ordinates here? Then here I expect that if they have asked you such, you are going to come and say, now for our case, what do we do? Now it means that instead of measuring 5-meter equal intervals, we can reduce and make them smaller, because you know that the more, like when you reduce like this, it means that you'll be able to get very many what? Very many strips. So that means your levels of accuracy. Even they may ask you to make a recommendation. Then you need to know that the width, you can say that the width of 5 meters should be reduced to maybe 2.5. Now, once you say like that, it means you are increasing the sub-intervals. Now, that one comes in after understanding the what? The scenario. But don't just say by increasing the sub-interval. Use the scenario language. That what do they use in the scenario? They use that at equal intervals across. That maybe you say that the interval should be maybe reduced. Maybe the number of strips should be increased. So you look at the scenario and then make a recommendation using the scenario language. But let's avoid now using the book knowledge or the book language that increasing sub-intervals, increasing what? Ordinates. Refer to the scenario such that you are more practical and it comes from an understanding point of view. So that is what we can. But whenever it comes to areas, dear students, do not forget that we are approximating and we use the approximation signs. Okay, let me take on one question from Lead High School.
Yes, thank you so much, teacher.
Yes.
Teacher, from this example that you have seen, I would like you to differentiate for us, like when they bring where you have to integrate or you have to draw that table and find those different y1, y2, and maybe y not. What makes it different from this scenario that you have just given us? Thank you.
Okay, thank you. Now, when do you have to integrate? Now, you integrate when they have given you a function to integrate. If they had given us a function to integrate, integrating means you are getting the exact value. Using trapezium rule, you are getting an approximate value. So whenever you use approximate value, whenever you use trapezium rule, you are looking out for an approximate. You are not so accurate, but your value is very close to the answer. That is the meaning. When you integrate, you are getting the accurate answer. You are getting the accurate value. That is the difference. And many times for you to use that, it comes when they have told you to calculate the error. They want to find the error between the approximated value and then the accurate value, or what called the exact value. That's when you go on and integrate. But once they tell you that they want you to approximate, then you use this approach, you draw your table, or you can just calculate directly. Okay, hope it is clear. The person?
Yes, it's clear. Thank you.
Okay.
Thank you so much,
Then
teacher.
lastly, okay. Bupadengo SS. Bupadengo SS, unmute. Okay. Lastly, Diana or Bruce, one of you.
Mr. Kajira, good afternoon.
Yes, good afternoon.
These opaque objects, I don't know if they are from your side, they are blocking the answer you write in your screen.
Come again.
There are these opaque objects which I do not know are on your side, they are blocking us.
There are some objects.
So,
Okay. You are going to, you are saying there are some, okay, there are some opaque objects, eh? Okay, but are you able to see what I'm writing? Do you see what I'm writing?
Meanwhile, I think you stopped sharing.
Yes,
I'm
I've stopped
seeing.
sharing. I've stopped sharing. But are you seeing what have you been seeing what I was writing?
I was seeing not until another one came in the middle.
And but you can be able to see the things I'm writing in the middle, right?
No, where the object is, I can't see.
Oh, okay. I'm going to try to see how I can minimize, but I think that yes, I'll try to see how I can minimize. But the issue I think came from. Okay. So let me share again, and then we can continue. Okay. Okay, so we are going to continue. For the black things that are there on the screen, I may not be able to remove them. Okay, but I'm going to try my best not to cover that space. So that is how you had to attempt that particular item. Then now we have the second part. When you look at the second part asks you that to accommodate workers at the site, the ministry has also acquired a rectangular piece of land measuring 123.65 meters in length, measured correct to 2 decimal places. And then what do they want? According to the site engineer, the campsite can accommodate the required 390 to 410 tents. Now, the ministry, you know very well that whenever we go in for construction, many times you want to have tents, small temporary tents, where people are going to be putting up, where people are going to be sleeping. Now, you ask yourself, how am I going to be in position to calculate that? How am I going to be Okay, so how am I going to be able to calculate? Now, when you look at my screen, this is what can happen in real life. That these are the small tents that we can have, and now they want to know how many tents can we have in this particular area? How many tents can we have in this area? Now, when you look at this item is bringing in the issue of errors. It is is testing you. Do you know how to obtain the maximum? Do you know how to obtain the minimum? So when you look at the lower boundary they gave us, they are testing in for that knowledge that the child, does he know how to calculate minimum? Do you remember errors? Do you know how to get the maximum possible errors? Now, that is what we are going to be looking at in here. So what are you going to do? I have told that always underline the math. So from here, they have told that they have acquired a rectangular piece of land. Then you can come and make a sketch. Say a sketch of the rectangular piece of land. Sketch of the rectangular piece of land. Now you can come and make your rectangular piece of land. This is the rectangular piece of land. Then they have told that the length, this is the length, is 123.65. Then its width is 95.774 meters. Now, what do you need to know? Now, when we are dealing with this particular item, we have the land dimensions, but do we know the maximum possible error we can get? What about the minimum length? So we are going to find that what are the errors in the length and in the width. So I'm going to first start with the land dimensions. I'm going to start with the land dimensions. So you ask yourself, when you look at the length of the land, the length is 123.65. But what errors do we have in the length? So you know that error is always given by 0.5 times 10 power negative n, whereby n is the number of decimal places. Number of decimal places. Now, when we look at our length, has 2 decimal places. So it means we shall have 0.5 times 10 power negative 2. And this will equal to 0.005. Please do not just come up with your things from the head. You show how you are getting it. Now, if we want the maximum error in the length, we are going to come and say maximum error in the length or maximum. So we shall say that maximum, the maximum what? Length. So we shall come and say maximum length is going to be 123.65, then plus 0.005, and we shall end up with our 123.655. What about the minimum? So we are going to come and say, what about the minimum length? The minimum length is going to be 123.65 minus 0.005. 5. So when you subtract 123.65 minus 0.05, you'll end up with 123.645 meters. Now, what about the width? So you still come and say, now I have my width. So what is the width? Is 95.774 meters. But you ask yourself, what is the error in the width? Here you can say error in the length. So this is 0.5 times 10 power negative n. But what is n? N is power negative 3. Because here you have 3 decimal places, 1, 2, 3. So what are you going to get? This is 0.0005. Now you need to find out what is the maximum width. So maximum width, it means that you are going to say 9574, then plus 0.005. So this will give us 95.7745. And now for the minimum width, you're going to come and say, what am I going to get? You subtract. So that one, when you get your 95.774 minus the 0.005, you end up with your 95.77. This is 3, 5, and these are meters. Now we are getting what maximum length can we have? Because remember, for any measurements we have, we shall always have some errors in those measurements. Now, what we are calculating now are the errors in each of them. So that is how we calculate them. So after that, you are going to ask yourself, this is why I want you now to think. Now you are going to ask yourself, how many tenths can fit within this? Remember, they told us that the tenths are this. So we are going to ask, how many tenths can we have in here? The reason why we are getting the maximum error, the minimum error, is for us to know how many in total can we have in there. So let me, I don't know whether it is a question. Chivale and Chivale community, is it a question? Okay. So we are going to continue. Now, after obtaining that, we are also going to come and ask, what about the tent? Then the dimensions, the tent space. So I'm going to come and say now, tent space dimensions. Now, what did they tell us? They told us that the tents, and even the ones I showed you, that they have dimensions. And when you look through the scenario, they told that the tent measures 4.5 and 6.85. It occupies a space of 4.5 and 6.85. And it is also rectangular. So it means that here I'm going to put 6.85 meters. And then here I'll put 4.5. Did I write 4.5 or 4.50? 4.50 meters. So still I'm going to come and ask myself, what is the maximum? So I'm going to come here and say, now I'm getting the error, the length, but I'm getting the error. So the error is going to be, since there are 2 decimal places, we shall say 0.5 times 10 power negative 2, which is 0.005. Then this is the length. So that means that our length, our maximum length for the tent is going to be 6.85 minus plus the 0.005. So for that one, we shall end up with 6.8. When you add 6.85 plus 0.005, it gives us 6.855. What about the minimum length? The minimum length, you just subtract minus 0.005, and this one is going to give us a value of 6.845. And these are meters. Now from there, we are going to say, what about the width dimensions? Then we come and say the error in the width is 0.005 because also it has 2 decimal places. So minimum width, we are going to just subtract 4.5 minus 0.005. we end up with our minimum width as 4.495 meters. What about the maximum width? Now, the maximum width is going to be 4.5, then plus our error, our absolute error, which is going to be now 4.505 meters. Now, after obtaining our maximum, we can get for the what? For the tent, and what we can get for the what? For the other one. You are going to ask yourself, because here I know, depending on how you are approaching. Remember, for you, when you are having a piece of land, for you to know how many tents you can place in, you need to know that in lengthwise, how many tents can fit in here? How many tents can fit lengthwise? So you are going to first ask yourself, what is the maximum number of tents I can put lengthwise? And what is the minimum I can put lengthwise? That is the first thing you need to do. That how many tents can I put lengthwise? So for you to know the number of tents you can put lengthwise, you need to know that if these are my tents and I'm putting them lengthwise, how many can fit there? What about widthwise? How many can I put when I'm calculating in that form? So I'm going to come here and I say now the number of tents along, because I've told you to communicate your work, number of tents along each side. So when I come at this point, I'm going to first say the largest, I can say largest or the biggest. I can say the maximum number of tents I can put lengthwise. So I'm going to say along the lengthwise. Along the length. Now, along the length, what does it mean? You need to know. If you want to maximize something, you need to remember from your knowledge, the teacher has taught you that I'm going to get the total length. This is the total length of the tent. And then you ask yourself, what about this tent I want? So that means that if you want to maximize something along the length, it means that always you get a smaller value divide by a very big what? Value. That's when you want what? Sorry. If you want to, this is minimize. If you want to maximize something, I'm going to get maximum divide by the minimum. I want to maximize something, the length. If I want to minimize something, I'll get minimum divide by the maximum. So we are going to first maximize how many tents can we have along the lengthwise. So I'm going to say here now, to maximize, I'm going to get the maximum length of the land, of the rectangular land, divide by the maximum length of the tent. Maximum out of, now this is going to be minimum because you want to maximize. So your maximum length from what we have calculated was 123.655. Divide by what is the minimum length of the tent. So when you come here, minimum length is what? You want to get the what? The minimum. You ask yourself now, the minimum is going to be what? That is where now the thinking has to come in. Now, when you are thinking, you ask yourself, remember when you are what? You are placing these things. You need to know that now I want to maximize, I want to minimize. So now you have to put the tents in that kind of what? In the kind of format, such that you know that along the length, how many tents can I put? And what about along this side, how many tents can I put? So that is what you have to do when it comes to this. So here I'm going to have the maximum length and then I'm going to have the minimum. But here now I'm going to start with the minimum width for the tent. So here, in fact, let me change this to be my width. So I'm going to come here along the length, the maximum we can get, because you want to maximize the length, but you want to minimize the width. So here we shall have 4.495. So when you place your calc, you'll have 123.655 divided by 4.495, which will give you 27.509. And this one is going to be approximately 27 tenths. Some of you may ask, why have we rounded downwards? The reason why we are rounding downwards, it is because you cannot have a half a tenth. Then you ask yourself, what about along the width? Along the width. Now, along the width, what are you going to do? Along the width, we are going to come and say that along the width, if I want to maximize, still I'm going to have my maximum. My maximum for the maximum width. However, if you still want to maximize the width, it means that now you have to minimize. What are you going to be minimizing? You are going to be minimizing the space for the tent. So here you are looking at the maximum width for the space of land that you have. This is space of land you have, and then you are going to look at the minimum. But now here you ask yourself, what am I minimizing? It means that here you are going now to minimize the length. So this one, we are going to have the minimum length. So now here, we shall come and see now, what is our maximum width? Our maximum width, when you check out, it's going to be, maximum. I want to be very sure what we got. Maximum width was 95.7745. So I'm going to come here and say, this is 95.7745 divided by, what about the minimum length? So you ask yourself, what is the minimum length? You just check from here and you say that it was 6.845. So what are you going to get? When you place your calculator, 95.7745 divided by 6.845, you'll end up with your answers 13.99189. Now here, you are going to still approximate, because this one is not a full 10, you are going to end up with 13. Now, if I want to know now how many tents can fit in that particular piece of land, how many tents can fit in that particular piece of land, what am I going to do? I'm going to get the number of tents that can fit along the length and the number of tents that can fit along the width. Then I multiply them. So I'm going to say now the number of tents. This is maximum wise. Number of tents is going to be 27 times 13. But because we are approximating, we shall come and say now, what is 27 times 13? And you end up that here, you'll get approximately, or we shall have, since in fact this one's rounded down, feel free to use equal sign, that we shall have 351 tenths. Now, if you are maximizing the space, you are maximizing the space you have, it means that the number of tenths that can fit in that area, that we have, is going to be 351 tenths. Yes, we are truncating. Okay, now I'm going to illustrate a bit here. I'm going to illustrate something here. Allow me to illustrate. Now, if I want to know the number of tenths I'm going to use along this, remember when you are placing your tent is going to have your length. Let me say this is the tent, and this is going to be the width. So I'll have something like this. So this is the illustration I can put. So lengthwise, if you are maximizing, you want to maximize to know how many tents can fit along that side, we can have around 27. If it is width-wise here, how many tents can fit around here? Remember now, width-wise here, we need to minimize the length of the tent. So now you cannot maximize length and minimize what? Length. So we shall maximize the length of the land, and then we minimize the width. So that's how you can calculate that. Now, I'm not going to go on and get now what if I want to get the smallest number of tents that can fit here? Now, in case I wanted to get the smallest number of tents that can fit within this area, it means that I'm going to come and say, along the length, how many tents can I put? So that means that I'm going to go back and ask myself, along the length, what am I going to put? It means that to get the minimum, I must minimize out of maximize. That is how you get the what? Still, I go along the width. It means that I minimize out of the what? Of the maximizing. Now here, when I'm along the length, it means that I need to compare the length. I compare it to the width. Remember, I never wanted to bring for you this formula that you know that area is like you having like the length and the width. So you are trying to use that kind of approach to know that what am I comparing these two, that you are trying to compare your length and you are trying to compare your width, such that you know what area or how many tents that can fit within that particular area. So in case you want to know the smallest number of tents that can fit with the area, it means that there you are going to minimize. So you get minimum divided by maximum. So for this case, when it comes to the length, your minimum length, I think we had 123.645. You get that minimum length, which is 123.645. Divide by now the maximum. What are you going to compare? You're going now to compare with the width. And what are you going to have? You're going to have your thing as 4.50. I think it's 4.505, something like that. And then now you come up with 27.45. Then you go along the width, and then also you compare your 95. I think it was 7735. Then compare it to the 6.855. Then that's how you can make those what? Those compositions. Okay. Allow me to someone is asking, would it be okay if I use, I'm going to first use the chart. Would it be okay if we use maximum area of the land divided by minimum area of each tent so as to get the maximum number of tents? Now, in real life, that approach, I would say it is 50%. However, like, you know, in real life, what determines the number of tents that can fit in an area is the length and width. Because you have to come, in real life, you're going to come and ask yourself, how many tents can fit here? But you don't look at the area in there. Because sometimes the area, let me say, in case this was a bit irregular like this, something like that, you cannot compare this width and you compare with the what? With the length. So here you need to know that what length do I have? Because remember, now I think let me do it more practically. Now, if this is our length and you want to put very many tents here, it means that practically you are going to come and say, if I want to put very many tents, I will put them like this. Are you seeing? I'm going to put them like this. If I want to put very many tents within the length, you will put them like this. Once you put them like this, what does it mean? It means that this is the width of your tent. So that's why we have been dividing length divided by what? Width. Because when you put them in this format, very many smaller tents can go there. That's what we call now the understanding point of view. But if you want to waste space, how are you going to put them? For you to put them like this. Once you put them lengthwise, it means that very few tents are going to fit. Let me hope now you have understood why we have divided the length divided by the width. So the reason is that once you put them lengthwise here, you are going to be putting few tents. But if you want to maximize, you want to know to get very many tents put along the length. What does it mean? It means that you need to be strategic. How are you placing your tents? That my tents, I'm going to place them like this, like this, like this. Hope hope you have understood why now I have placed them here like this, like this. Yeah, hope that is okay. I'm going to you can let me know in the chat why we have got length out of the width. So allow me to respond to two questions. Kivale Secondary and then Riverside High School.
Thank you, sir.
Yes.
Our question is in the first part. Like you rounded off, like your answer was in just 2 decimal point. Are we not limited?
Where? Here? Sorry? Here?
On part A.
The trapezium
Here.
rule.
On part A.
Oh, on the trapezium rule.
Yes.
Yes. When you look, what do you get when you place your calc?
We get we get 63.85.
85, and that's what I have.
So what if like we get like 3 decimal places?
No, now here, since when you place your calc, you get this. You cannot put now 850.
Okay, now when we get like 3 decimal places, like 63.851, we put all the decimal places.
Yes, place at least 4 decimal places.
Okay.
At least 4 decimal places.
Thank you, sir.
Second question.
Yes.
Second question on part B. When arranging the tents, how do you know that you are going to leave some space or parts?
Now, now are you seeing those errors? The errors we are putting.
Yes.
What we are adding and subtracting. Now, those are like what we are going to consider as the spaces.
Okay.
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 Thank you, sir.
Okay. Riverside. Riverside. Am I failing to get Babilio Christine or Mukula Memorial? Yes, Riverside.
Good afternoon, sir.
Yes, good afternoon.
My question is about the rounding off. Why do we round off downwards, and yet when we round off upwards, we at least get a number of tenths that is approximate to the range that is given in the scenario?
Okay, now when you look at what we have obtained at the number of tenths, but we cannot have 0.95 tenths. Are you getting it? So we cannot have and have a tenth.
No,
So that's why we...
Sir.
Yes?
Here, 27.509. You say that we get 27. Why is it we don't make it 28? And here at 13, we make it 14.
Okay. Now, when you look at this value here, these are the number of... This is like the number of tenths that can fit along the length. Now, but when you look at them, you note that this number of tenths has 0.509, which is showing that this is half a tenth. So we cannot have half a tenth. So having a half a tenth, you'd rather leave it because they are not going to cut the tenth into a half such that it fits. It means that a full tenth cannot fit in that space.
Okay, sir. Thank you.
Okay. So this is where you go back to real life and then compare.
Okay.
Yes.
Sir.
Yes.
Sir, I would like you to go back to the other side where you said that for you to get them along the width, where you divided that the maximum width is divided by the minimum length. Why not the maximum width divided by the minimum width? There we are not understanding.
Okay. Now I'm saying I want you to place it in real life. Real life. If these are your tents, are you seeing?
Yeah.
If this is your land and you want to put very many tents along the length, what are you going to do? You are going to put them in small, you are going to place them like this. such that the width is along the length. That's what you can do. That's why when you look at class, whenever you find that your class is very small in school, they will put your benches like this. They will put them like that. That's how they are going to place them. Why? Such that very many benches or very many seats can fit. When you go to let me say, when you have gone to parties, the reason why they put chairs in this form is that they want to maximize. They want to get many. But if they don't want, then the arrangement will change. Now, if you have, this is your piece of land, and you want to get very many tents here, it means that you are going to put them vertically like this, such that the width is here. However, if you want to note the smallest number of tents you are going to put, then what are you going to do? Along with your length, put them lengthwise as well, such that now more space is wasted. That is the meaning, like that. So lengthwise goes with lengthwise. If this is your tent and you want to waste space, you put them what? Widthwise, something like that. I don't know whether you have understood now.
No understood.
It
Sir,
is fine?
another question. Yes,
Yes.
but there is
Okay.
another question. Sir,
Yes.
how about if you go ahead and find the area of the land and this one of the tent, can't you use? Mm.
Now, I have said, when you use
And
the area of the land in real life, when you look at real life, the area of something, because there you are not able to leave out some areas. And in case that land is not regular in shape, it means that you are going to misuse some of the space that you have. I don't know you're getting it. That's when you try. I know some of you want that we calculate the whole area of the whole thing divided by what one small tent contains. But when you look at that whole area divided by what one small tent, you'll notice that your tents are going to be on each other, on each what? Other, without leaving anything. So practically in real life, that one may not work. It's like when you want to, like you have gone to bonds of cars. You have seen bonds of cars. You have seen how they arrange things. For you to know how much is going to fit here, you first place and say that these are the numbers, and then like that. But I know that approach, once you use it, you will get an answer approximately that is a bit high than this one here.
Okay. So how about the other number one, the zero? That zero in the that we substituted in the formula, we don't get it. Like, where did you get that zero from?
Now, remember, when you are dealing with the trapezium rule, the y naught and yn stands for the height. Remember, when your teacher was teaching you, he told you that in case this is my trapezium,
Yeah,
this is your y naught, and the last value is your yn minus your yn. The last one is yn. Now, this one, y naught stands for the first height. It stands for this vertical height. When you look at our bank here, its starting height is 0. Like when you draw like this, you notice that it is what? It is 0. So y naught here is 0. This is y1. This is y2, like that. Have you understood?
Yeah.
Yes, sir.
Very well.
Okay. The rest you are going to allow me that I'm going to respond to those questions in the chat. But like I've said, you need now to know, this is the pictorial thing I showed you, how you can minimize and maximize. So the way you position your tents, the way you put your tents matters a lot. How are you going to put them? Are you going to put them lengthwise? If you want to use the lengthwise very well, it means that you must put them widthwise. If you want the widthwise to be used well, what can you do? Now, that is the kind of reasoning that you need to go with. That's why these items, they require you to think, such that you can be able to do them. Yes, I think St. Adolf, I have responded to that question, why we divided. But I want to respond the last time. I have said that when we are when you want to get something very big, that's what we call maximum. If you ever want to get a big value, you'll always get a big value divided by something very, very small. That is the meaning. That if you want to get something very big, get something that is big divided by small. That's why down we are minimizing. Up we are maximizing. Like we want to maximize this length here. But in order for us to maximize this length, how we place our tents matters. If I want to maximize, it means that I have to place my tents like this, in this format, like this, such that very many tents can fit in a lengthwise format. But if I'm to place my tent like this, very few tents are going to go. So you are not maximizing, but instead you are wasting. But if you want to go on and look out for the let me say for the smallest number of tents to use, then you place your tents like this, lengthwise. Now that's why I told you when it came to the second part that if you want to get the smallest number of tents that can fit into the area, then you have to put them lengthwise, widthwise. So that's how you can keep on wasting. So you get the minimum, and you remember to get a smaller value, you always get the minimum divided by the maximum. So here you look at remember here you're comparing this length if you want to waste, or if you want to know the smallest number, you get this length, and also you get the lengthwise of the what? Of the tent. You put them lengthwise like this. So that means that you'll be now wasting. So you get the maximum, and then you divide by the other minimum. So that's how you can deal with that part. But allow me that now for this part, I will stop at that, and maybe we shall make a conclusion. So when you look at the conclusion, we have already obtained that the maximum number of tents that can fit are 351 tents. Now, what are you going to do? You must make a conclusion, compare the values they have given within the scenario, and then you make a recommendation. So when you look at that, you know that from what our calculation, the campsite can only accommodate 351 tents. And when you look at 351 tents, they are less than the 390 or the 410 tents. So what does it mean? It means that the space that the ministry has obtained to put the tents is not sufficient, does not meet the required number of tents. The ministry wants to place in there. So in case they have asked you to advise, then maybe you can advise that maybe the ministry should maybe look for more bigger land, or in case there is an opportunity, they can expand the land. If there is an opportunity, they could reduce the number of tents to go in the area, such. That's how you can conclude. Okay. Allow me, in case of any questions, place them in the chat. I know we have teachers on the call who can be responding to some of those. Okay. Okay. Now, allow me to respond to the last person. Someone is saying that I've divided the maximum of the land with the maximum of the tents. Now, if you divide big and big, what are you finding out? So, mind you, when you are maximizing something, we expect that for you to get something very big, you maximize and minimize. In case you want to get something very small, you minimize and maximize. So, James, kindly check out that. Okay, so we are going to continue. Now, I want to show you other applications. When it comes to the trapezium rule, they can as well, like I've said, that always identify the concept. So here, like as I was starting, I told you that now we are using the trapezium rule. When you check here, they can bring for you, like you have seen, some of you have been to, you have seen some of these things happening. So they can ask you something. I think this is equivalent to something given that is in Kampala. Some of you have seen roads that pass under. So they can ask you something of this nature. Now, if something was, let me say, irregular, like someone was asking, what if it is circular? What do we do? Now, for such, using an approximation method can support. But also you need now there, you can use the approach of area, but the approach of area will bring out a lot of issues. But always we look at the kind of, now in case it is circular, then they may give you something that is also circular. Take an example, they can tell you round tables, things that are round. Always we want to compare shapes with the same shapes. Now they can tell you here to estimate the area. They can tell you to estimate this area you see here. Now here, for you to do it, they can ask you to use the approximation what? The approximation method. Now you need to know, how am I going to apply? They can give you a function, but they may tell you that they want you to use the approximation method. Sometimes they can even tell you, because now here you need to understand, they can come here, they put for you values. They put for you values like that, and they tell you use an approximation method. Now, as a student, you need to know that, hey, if I'm to use an approximation method to estimate this area, I must come, I draw my trapeziums. And when I'm drawing my trapezium, I must ensure that the width of the strips is uniform. So you come here, you draw your uniform strips, 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 like that. And then what you need to know is that this one should be the same. So now it is up to you now to know that I can set 10 minus 0, and then I get my own interval. Maybe I'll leave a space of what? Space of 5. Now, please do not cram. You need to understand, because these scenarios can be set in any way such that they test whether you understood trapezium rule, not you telling you that we have this function, use this number of what? Ordinance. So now they may ask you, use an approximation method to estimate the area of this curved area, or to estimate the area of this. Now you need to know that there I can come, I draw my trapeziums inside, and then from there I come up with the different what? With the different trapeziums. So please be very careful and understand the concepts very, very well. They can also give you a curve of this nature, and they tell you, estimate the area under this curve. They can tell you this is a water body, and they may ask you to estimate the area. Now you need to know that, now what am I going to do? I'm going to come and I draw different trapezium. I can draw here, I can draw another one here, I can draw another one here, I can draw maybe another one somewhere here, I can draw another one here, like that. Now here you need to know that now your total area is going to be area 1, area 2, area 3, area 4, area 5, and area 6. So now that is the kind of understanding that you need to know. And now you need to remember that now your y naught for this first one here is not going to be 0, but instead is going to be 8 point what? 8.5. So meaning that when you are writing your rule here, you will say that my first is 8.5 plus what is the last one? The last one is 0, then plus 2, then you start now getting this height, this height, this height, this height, this height. Now that is now the understanding. Then when you are looking for h is the width between the trapezium, that here the width is 0. What? 0.5. So here you put 0.5 and then you approximate. Now please understand that they can give you any shape and they're asking you, or they are looking out for the understanding of a particular thing. Okay. So let me hope this is very, very fine. So please be mindful on how to use the trapezium rule, how it can be applied in practical life or in practical situations. So that's how you can go about it. But I'm seeing a hand up. I'm going to pick 2 hands. Yes, Bwanga SS, and then maybe Richard. Unmute. Only 2 people. Okay. Now, since they are unable to unmute, Gwanga SS. Okay. I think I'm going to go on. So now we are going to go to the second item. When you look at the second item, we are looking at data analysis and probability. When you look at this particular item, I mainly focused on the item went on like this. But whenever you meet these scenarios, dear students, look at the scenario and then understand, what does the scenario want me to do? What does the scenario want me to find? Then that is the best way to approach it. Ask yourself, what does the scenario want me to do? And what is the scenario wanting me to do? Now, when you look here, they are telling us that an education officer has conducted an assessment evaluating the performance of the children. They have got some marks and they have got a number of learners. But mind you, this is just a sample of some of the learners within these institutions. Now, when you look at this item, it is combining data, mostly the descriptive part of it, and it is also combining probability, which is normal distribution. Now, when you're approaching this item, I want you always to first read the scenario, interpret it, and find out, what does the item want me to calculate? What does the item want me to do? Now, when you look at it very well, the item is asking you that before preparing the assessment report, the committee requires the distribution of learners' marks to be presented graphically so that the most common mark attained can be identified. If you place for me in the chat quickly, dear students, schools, what kind of graph do you think this scenario is asking you to do? Put it in the chat. I want to just look through the chat. What thing do you think the scenario is asking you to do? Which kind of graph? Very good. Eden High School has said that they're asking me to draw a histogram. But you need to know, what is it that is asking? It means that they have asked for most common mark. When they ask for most common mark, it means they're asking for the mode. So for you to be able to estimate the mode, you need to know which kind of graphical presentation you are going to use. And that one is a histogram. Now you place here that here I will need a histogram. Then continue. The committee also reviews the variation in learners' marks to establish whether learners performed consistently. Now, if I may ask, still put for me in the chat, what kind of calculation, what kind of dispersion do you think they are looking for in that scenario? For that part, variation in learners' mark. Because it is not directly, now you need to know, what do we call variations? When they were teaching you descriptive statistics, now, you need to know the variation. Variation, we are looking at how far are your values spreading from the mean. So the variation here, dear members, we are not looking for variance. We are looking for standard deviation. It is standard deviation that measures how values differ from the mean or from the measure central tendency. This question, when they ask, you know very well that we have what called central measure tendencies. That is mode, mean, and median. Now, when they ask for variation, now it means that now you need to look at the measures of dispersion. And those measures of dispersion, it can be interquartile range, it can be range, or it can be the standard deviation, at worst variance. Okay, now we continue. So here you take note that here they want me now to find standard deviation and identifies the middle 60% range. Now, middle 60% range is what I'll focus on. Now, after you knowing what to calculate, look at your data again. Before you attempt any statistics number, please first check out, are my class limits consistent? If your class limits are not consistent, please take note of that. Now, when you look at this kind of scenario we have, it was testing you. Do you know how to draw a histogram? Do you know how to deal with class limits that are different, whereby the class width is different from each other? Do you know how to calculate standard deviation? Do you know what now to include? Now, you are going to plan. You know that I need a histogram. You know that I need a standard deviation. I will need the range, the middle 60% what? Range. Now, I'm going to go to the planning phase. I'm going to go to the planning. Now, as I'm planning, I'm going to ask myself that from the scenario, I've said I need a histogram. What do I need on a histogram? When you look at the class interval here, you notice that the class interval is different for each. When you check here, you notice that this is 10. When you check here, you notice this is 5. When you check here, you notice this is 10. So you notice the class interval. Now, meaning that if you are drawing a histogram, you will need what to call frequency density. Now, here you are planning how to approach the scenario. You are unpacking the scenario. I will need frequency density. What else? I will need the class boundary. Now, this is your planning. Then, when you continue, they ask for the common mark. So here, I need to estimate the mode. This is in your plan. Then from there, even another student can go and say histogram. It means that I'll have frequency density against the class what? The class boundary. Then now, and you are going to go, what else will I need? I will need the standard deviation, the variation of the values. Now, you need please to understand that standard deviation measures how your individual data, how your individual mark deviates from the average. That's what we call variation in learners' marks. It tells how far your marks scatter from the central tendency. Because since they had already asked you for a central tendency, what does it mean? It means that now here they were asking you, do you know how to calculate how far your marks differ from each other? Sometimes in class, you're going to find yourself that someone had scored 80 and another one scores 30, another one scores 90. Then the teacher will come and tell you that the performance was bad. But what makes the performance of your marks? In case, let me say in your class, you have 80, 88, you have 89. This is how students scored, and 84. Now, this one I can see that the performance is good. Why? Because the deviation, the way the marks are scattering from each other is very small. Now, here when you make your calculation for standard deviation, you are going to see that your marks are varying, are good. They are not varying very badly. But if you find that in your class you have 90, another person has 45, another one has 10, then you have 15, you have maybe an 80. Now, this performance is very bad. Once you obtain the average mark and you calculate the standard deviation is going to be very big, which shows you that the variance, the way the marks are varying, are very bad. Now, that one is a very bad what? Performance. Now, that is what we call standard deviation. So that's why I'm saying you need now to understand the mathematics, but not just cram the formulas. Now, here you need to know. Now, if I'm to calculate the standard deviation, what will I need? That for standard deviation, I will need f of x. Standard deviation, I will need f of x what? Squared. Place them. And then know. Do you know the formula? That the formula is always summation of f of x squared out of summation of f minus summation of f of x out of summation of f, everything what? Squared. Now you know that that's what you need. Then go and ask yourself, I have the middle 60% range. Now here you need to know that for middle 60%, what are those things that I'll need? That I'll need cumulative what? Frequency. Cumulative frequency. What else will I need? That make class boundary, but class boundary have been captured already. Now, this is what you call planning for your work. Now, after planning your work, you are going to specify how are you going to present your data? How is your data going to be presented? Now, you need to know now which things I'm going to put in the table, which order am I going to follow. And I want you always to know that always the things that have been given in the table, sometimes they're going to give you the table, sometimes they may not give you the table. But the moment they give you the table, the way you have extract the first two columns must be extracted directly from your scenario. Don't create your things, but let the first two columns communicate how you have obtained your data from the scenario. So allow me to pick one hand from Light Vocational and one hand from Rena College. Yes, hope, and please ensure that what you are asking now it's about this, because I'm not going to move backward. Yes.
Good evening, sir.
Come again.
Good evening, sir.
Yes, good evening.
So on that formula of finding the standard deviation,
yes,
we came across that sample which was released. Whenever they use sample of learners, they use the unbiased unbiased, that formula of unbiased something, having summation f over summation f minus 1. Are we not supposed to use it here?
You are saying whenever you find,
whenever they use sample of learners, we always use that formula having summation f over summation f minus 1, then that one which you have indicated, this one. Yeah. Are we not supposed to use that one instead of one
yes
given?
Now I'm going to talk about that. I'm going to talk about it at a later time.
Okay, sir.
Instead of okay, I think I'm going to talk about that. I think let me first continue and then I will come back again. I'll come back again. Okay. Okay, so let me first complete. Now, what are you going to do? You are going to first indicate for us what kind of distribution is this? That is the first thing. I want you always to know that you are going to tell us that a frequency distribution table. Let me put this black thing down. Let me put them down. So I'm going to first say a frequency distribution table. And what is the table showing? Or what is the table having? Showing the marks scored, or the marks depending on the scenario. So you can say the marks are of different learners. So that's what you can do. Now, after that, I'm going to represent my table. I'm going to represent my table. I'm going to represent my table. So when you look there, they gave you the marks. So I'm going to put, and they gave you the units that they were in percent. So I'll put the marks there, that the mark we had 20 to 29. Kindly place your questions in the chat. I'll be able to look there. 30 to 34. Then we shall have 35 to 44. Then I'll have 45 to 49. Then I'm going to have 50 to 54. Then I'm going to have 55 to 59. Then I'm going to have my 60 to 74. So from there, allow me to close the table. Always make sure that your table is closed. I'll have number of learners. I'll have number of learners. Now, number of learners is your frequency. So put in bracket that this is frequency. So I'll come and say, what's my frequency? Is 9. This is 12, 27, 13, 25. This is 18, and this is 30. And there I'll put summation of F, which is 134. Now, when you look at our planning, the item started with histogram. So we are going to first work with things concerning histogram. So for histogram, what do we need? So we noticed that we wanted the one of them was the class width. So I'm going to come here and say, now I'm going to first check what are the class width. Now, when we are obtaining the class width, remember, I'm going to put here, you are going to say 29 minus 20, then you add a 1. So when you subtract, it will be 9 plus 1, which is 10, because these are whole numbers. So I'm going to remove that, and I put here that here the class width is going to be 10. Here we shall have 5. This is 10. This is 5. This is 5. This is 5, and this is 15. Then I'm going to look at, now the next one is going to be frequency density. So I'll come here and say frequency density. How do we get frequency density? Remember, it is frequency. Now here, class width, I can put C. So it will be F out of C. So that means that you are going to get your frequency divided by class width. So when you divide, this is 0.9. So for you, just look at your frequency, which is 12 divided by 5. Get 27 divided by 10, and then we work on that. So here I'll have 0.9, place you get 2.4, this is 2.7, this is 2.6, this is 5.0, this is 3.6, and then this is 2.0. Then from there, what else shall we need? It means we need the class boundary. So I'll come here and I say now I need the class boundary. So now my class boundary, I'm going to get it. We say that when you are obtaining your class boundary, for the whole numbers, you will subtract 0.5, add 0.5. So I'm going to come and then I do the same. So here, when you subtract, you'll have 19.5 to, this is 29.5. This is 29.5. This is 34.5. 34.5 to 44.5. 44.5 to 49.5. 49.5 to 54.5. 54.5 to 59.5. Then this is 59.5 to 74.5. Now, okay. So we have said that whenever you find that your class width are different, it is an indicator that in case they have asked you to draw the histogram, you need to use the frequency density. So for you to get frequency density, get the frequency divided by the class width. That's how we obtain it. But I'm seeing some hands up. I don't know. Kitatia, unmute. Bobulo Gauss, unmute.
Yes, good evening. Sir, good evening.
Yes, good evening.
Anyway, my question just want to
Ask.
We just want to we request you to mention some of the words they should use when requesting for variance and mid-range.
Okay, I'm going to talk about them. Okay, I think, okay. I think, allow me to go to the questions afterwards, because some of those things I'm going to respond them. Now, after that, what else do you need? You need to get your mid. Now, this being max, so I expect you here to say mid mark. And then put in bracket that this is x. So to get the mid mark, you add and then divide by 2. So you'll come here, look, you can, if you want, you can add the class boundary, divide by 2. If you want, go to 20 and 29, add, divide by 2. So whatever thing you use, you'll get the same. So we shall say 20 plus 29, everything divide by 2. Sometimes some of you have this habit of doing like this on your calculator. This is mathematically wrong. The calculator is going to give you a wrong answer. Always ensure you put the brackets there. So now here, our mid-mark, we shall have our 20.45. We are going to have our 32. We are going to have 39.5. We are going to have 47. We shall have 52. We shall have 57. And we can have 67. Then from there, we are going to come and then go on and have the next one. Is going to be f of x. Now, since we have already obtained what f is and what x is, we are going to multiply this times the x. So you are going to multiply your 9 times the 24.5. So here, you get this. This is going to be 384. This is 166.5. This is 611. This is 1300. This is 1026. And this is 2010. So our summation of f of x is equal to 6618. Okay. Now from there, we are going to go on and have f of x squared. F of x squared. So f of x squared, multiply your f of x times the x. So when you multiply, I have 5402.25. I have 12288. I have 42126.75. I'll have 28717. Then I'll have 67600. I'll have 58482. And then I'll have 134670. So that is that. So you'll have your f of x squared. And here you'll have 349286. Now what next? I'm going to have, the last thing I'm going to have in the table is going to be my cumulative frequency, because I'll need it. So I'll put here cumulative frequency. So you know your cumulative frequency, get your frequency 9. After getting the 9, you come, add it on 12, get the value. The value you get here, add it here, like that. So we are going to get that. So this is 9, this is 21, this is 48, this is 61, 86, 104, and this is 134. So that is our table. But make sure that your table is a talking table, that whatever thing you are going to be using, it is included in the table. Yes. In case you have recurring decimals for frequency density, I always advise write them as fractions. But in case you are going to plot, you are going to use them for plotting, write to 2 decimal places. Please make sure that you don't abbreviate, because if you use CB, someone doesn't know what is CB. If you use FD, those things are not defined unless when you have defined them outside the table and then you use them. But please don't use signs that are not defined. Okay. Now, I know all the other questions I'm going to be responding to them. So allow me to proceed for now another minute. Now, what are we going to do? We are going now to start. You are going to allow me first stop sharing for a minute, and I ask you to get your graph books. Get your graph books. Get your graph books. Get your graph books such that we plot together, because now we are going to plot that graph together. We are going to plot that graph together. So you get your graph books. Those who have not yet plotted, get your graph books, and then we are going to plot it together. We are going to plot it together. Just give me a minute. Okay, I'm on. Just give me a minute. Okay. Okay. So, hope I'm just organizing something such that we can plot together. Okay. Let me hope you have obtained your graph papers. Yeah. She's called Winnie. So you check out for Winnie. Has she concluded? You check. Eh. Okay. Hope people have got their graph books. Okay. Hope my screen is back. So I wanted to first come to our histogram. This is now our graph. So for our graph, always we shall start with the title. What is your graph all about? That it is a graph about histogram. So I'll say histogram showing marks scored by learners in a mathematics assessment. Now that's what you do. Then the next thing, I know, hope this thing is not going to, from there, you are going to draw your graph. So I'm going to come here. I'm going to draw my line. I can leave 1 centimeter or I can leave 2. I'll draw my line like that. Then I'll also come horizontally I'm going to cover this upper part. I know you may not be able to see it, but I think I'm being limited by some of these tools. So I'm going to come here and I draw the horizontal one like that. Then from there, I'll put my axis. I label very well. Then from that, I'm going to put, from the question, you had marks. Marks are your class boundary. So I'll put here marks and I put in percentage. Now, what are you noticing? When you look at one of the mistakes that many times children do is that children do not here, they don't get equal classes. So when you look at our class boundary, it is 19.5 to 29.5, 34.5, 44.5, 49, 49.5, 54.5, and so when you look here, you notice that the class intervals are not the same. So on your graph, you must have class intervals that are the same. So when you come here, I will start from 19.5. Then I can jump to, I said this is 29.5. I will jump to and I said this is 39.5. Jump to, say this is 49.5. Jump to, this is 59.5. Jump to, this is 69.5. Jump to, this is 79.5, like that. So make sure that the class width in between when you are plotting is the same. Then along the vertical, when you look at our frequency density, when you go back and look at your table, you notice that your frequency density was between 0.9 and 2. So I can decide to use 0.5 as my scale. So I'm going to come here and say 0. This is 0.5. I'll jump to, this is 1.0. This is 1.5. Jump to, this is maybe 2. This is 2.5. This is what? My graph is not going to fit. My graph is not going to fit, but yours will fit. 2.5. This is 3.0. This is 3.5. This is what? This is 4.0. So please, you go up to 5. Go up to 5. Mine may not fit unless now I change my scale. But I can change my scale and I start 1, 2, 3. Maybe that's what I can do, such that it fits and then people can see. Let me change my scale. Let me change my scale. But for you, that scale can fit. Your scale, that scale can fit. So I'm going to start with 1. I go to 2.0. I got 3.0. I got 4.0, 5.0, 6.0. It fits. Then here I'm going to write frequency density. Now I'm going to start the plotting. When you look at the first one, you are plotting your frequency density is 0.9. So I'm going to use this ruler to be able to plot. Allow me to pick this. Yeah, it is 0.9. 0.9 is here. So I'm going to come here. I draw my bar. I draw my bar like that. I draw my bar like that. Then from there, I'm going to go to the next one, which is 2.4. But when you look at 2.4, goes between 29.5 and 34.5. 34.5 is in the middle here. So you'll come and say 2.4 is somewhere here. I'll come like this, and then I go like this, something like that. Then you go to the next one is 2.7. 2.7 is somewhere here, but it goes up to 44.5. So you'll notice that one, when you go to that one, it's going to come, that is what? 44.5. So 44.5 is somewhere here. So you'll find it is here, and then your graph will come like this. Then the next one is 49.5, and 49.5 goes with the 49.5 goes with 2.6. So 2.6 is slightly here down. So it's going to be something like this, like that. Then the next one is going to be 5. So 5 is where you come. 5 is here. And 5 goes with 54.5. So where is 54? I think 54 is here. So then you come like that. Yeah, I think then you go to the next one, which is 3.6. 3.6 is here, somewhere here, and 3.6 goes with the 59.5. So here, and then you come here like this. Then the next one is going to be 2.0 and then 74. So 2.0 is here and then 74, which has to be somewhere here in the middle, and then you come like that. So that's how your graph can be. Now, after drawing your graph, you are going to estimate your mode. And when you are estimating, please show how you are estimating. So we know that I'm going to come, I draw a line here, I'll come here, I draw a line here. Then the two lines where they meet, I'll come down here, and then I'll indicate that that is my meeting point for my mode. So from what I have here, I can tell from my graph here that what I have for my common mark, I'm going now use the language used in the scenario. I'm going to use the common mark. The common mark is going to be 49.5 plus. When you look at my boxes here from my graph, I have 2.5 boxes. That's what I have. So now it depends. I know some of you, they can be 3, they can, depending on how accurate you are. So 4.95 plus 2.5, which is around 52. And now this is a mark. So you say this is percent. So it is going to be 52%. Now that is how you plot. Whenever you use frequency density, you will notice that the size of the bars you are coming up with are different. And now that is what makes the histogram different. And always make sure that the class interval you have is well spaced. That one will make your work totally different. So that one, you pay attention to it. You pay attention to that particular aspect. Okay, now I'm seeing this hand has been up. I don't know what the question is. I want to, is it Coley? Coley ask? Coley comprehensive? Coley, your hand has been up. Okay, Coley is not asking. St. James? Yes?
Good evening, Master.
Yes, good evening.
What I'm asking is that when do we use a frequency table and a frequency distribution table?
A frequency table and a frequency distribution table.
Yes.
Are they different?
We need some clarification about that.
Oh, maybe another. Now, when it comes to a frequency table, comes from that your table contains frequencies. So when it comes to presentation, we have a frequency distribution table. There is nothing like a frequency table alone. When you say a frequency table, it means that your table only has frequencies. That's the meaning.
Okay, thank you.
Okay. So allow me to continue. Allow me to continue. But let me give me minutes as I stop sharing. Okay. Around them, but okay. Now that is how you had to approach that particular part. Now, after that, please, you are going to go on and we have finished the first part. Then, when you go to the next part, they ask that the committee also reviews the variation in learners' marks to establish whether learners performed consistently and identify the middle 60%. Now, I know like someone was asking that here now they have said the sample of learners. Now, one, that for this particular aspect, the meaning of sample is not the population sample where they just picked. So here, we are not going to stick. One of the things we are not going to use I know here some of us, I know you wanted us to use 1 out of n minus 1, but that one, I would advise that it will come in a lot when we have population samples. But for this particular one, we are going to stick to this particular formula. But I'll give you a scenario where you need to use n minus 1 in your sample. And for those particular scenarios where they are intending to use n minus 1, they will even tell you, they will give you like the sample number of what? Of learners. But here, we are only going to stick to this one because I'm going to show you why we are going to stick to this one and where the variation is going to come about. Now here, like they have told you, like I told you, you need to know the meaning of what we call standard deviation. When we talk about standard deviation, we are looking at how your scores are scattered. How your scores are scattered from other people whom you have done the same paper with. When we are talking about variance, variance is the mathematical measure of the spread of the max. Variance is like the calculation. Then standard deviation is the interpretation, is the practical measure. That is the difference between two. Variance, you are looking at the mathematical measure of the spread of the marks. That is the calculations. Then standard deviation, you are looking at the practical measure. You are looking at the interpretation. So whenever you are interpreting, let me hope in your general paper, when your teachers are handling data analysis, you might have noticed that when you were interpreting the results you have obtained from your questionnaires, you looked at the mean and you looked at standard deviation, because it is standard deviation that shows you how things are scattering, how things are varying from each other. So now that's what now the question here wanted. And you need to understand the scenario and relate to real life, that if I want to know how my performance varies from the average mark, then it means that one they're asking for standard deviation. Don't just rush and then say, now I've seen variation. This is variance. Variation doesn't mean variance. Yes. So we are going to come and obtain our variation. So we shall come here and say our variation. We are going to come and say now our variation is going to be summation of f of x squared out of summation of f into summation of f of x out of summation of f squared. So here, some of you want to use the formula, want to use the symbols. Please, if you are not sure about the symbol, don't use it. Don't commit yourself to use it. Don't just come and use this, and don't come and say SDR. Now, since the scenario is talking about variation, you come and stick to the language used in the scenario. So here we shall come and say this is 349286 out of 134 minus 6618 out of 134, everything squared. And here, when you make your calculation, this is 167.43, 14989, and then we shall end up with 12.9395, and this is the percent. Now, whenever you are comparing the variation, we always compare variation with the average or with the mean. I want you to remember, I hope in your general paper under data analysis, you have looked at how you analyze data. Whenever you are analyzing data and you are looking at standard deviation is always calculated or is always compared to the average mark, or always you compare it using the mean. So when you are making such conclusions, always know that if I'm comparing standard deviation, I must always compare it with the mean. So this is your standard deviation for that. So when you look at, again, I'm going to take you back to the scenario. Remember, we have not yet concluded. We have not yet concluded at all, but we are going to conclude at each of those steps. Then they asked you that the committee also reviews. Now, the first one, the distribution of the marks, please you go on and conclude. Then the evaluation to establish whether learners performed consistently and identify the middle 60% range. Now, what does it mean for this? Now, when you are making your conclusion for standard deviation, you cannot say that something is consistent if you don't know how the students, what was the average mark. Because I've told that standard deviation shows you how individual data deviates from the average, how the values students have scored are deviating, are moving away, are spreading, are scattering from each other. I've given you an example. Take an example in your class. Someone scores 90, another one scores 12, another one 30, another one 20, another one maybe 40, something like this. Now, you'll find out that when you calculate the standard deviation for this particular class, your answer you are going to get at the end is going to be very big. Why? It shows that the values, when you look at the minimark, you are going to find that the way the values are spreading is not good. So for such a case, it means that for that, you are going to go on and even make a conclusion. Going to go on and make a conclusion. So you are going to allow me to show you something for standard deviation. Hope I have it here. Okay. Sorry, I will show you at the end. I'm going to show you about the standard deviation, but that's how you point it out. But now when I'm commenting, I want you, dear students, to know that when I'm commenting, I'm going to make my comment basing on this standard deviation, but the mean. So for this particular item, if you are making a good conclusion, I would recommend that also find the average. I find the average mark. You could use the mode mark as one of them, but also you could find a mean, because always standard deviation is compared with mean, not any other central tendency. So here, when you calculate your mean, you'll find that your mean is 134. Your mean is going to be 49.388. Now, if you are looking at those people who do, okay, all of us do math. Now, when you are looking at the way your values are spreading, you can even use your normal distribution curve, and then you look at how I know you have done normal distribution, so you can look at your curve and then check out how your values are spreading. That if this is your average, to be able to get the next person, you add or subtract 12.5. That if your average mark was 49.388, to get the next value, it is positive or negative 12.9395 to get the next mark. So you'll find that if you are getting the next person's mark, you'll say 49.38 minus 12.9. Then you'll find that the next person, someone had 36. And to get the next person maybe above, you add and subtract. Now that's what I wanted to bring to your attention. Now when you are comparing such, that's how you can. But I want you to know that the smaller the standard deviation, the closer the individual score. If the standard deviation is very small, it means that your marks, the way you performed, all of you, let me say if the whole class gets maybe 90, 80, 89, 90, 90, you'll find that here, your standard deviation is going to be very, very small. So that means that your performance was moderate. All of you scored almost the same value. But when the standard deviation is small, it means that the individual score tended to be from like your individual scores are very close to the mean. When your standard deviation is very big, it shows that now that is very dangerous. Those are the classes where you're going to find someone has 90, the rest of the children have 30, 20. Now that one is very deadly. It means that your performance is not evenly distributed. One person performs well and many children are failing. So please use your knowledge you have attained from your GP under data analysis when you are looking at how you analyze your data for your questionnaires and apply that same. But also hope your teachers, when they were handling standard deviation, they were able to tell you how to interpret it in real life. Then, okay, let me first check on the comment. Okay, I'm going to continue. Then the last part that we had to comment on was the middle 60%. Now, for you to do the middle 60% of your data, let me say this is our scale. This is 0 and this is 100. I'm going to first come and say middle 60%. I can have this. And I say this is the 60%. Now, if this is 60%, you know you are working out of 100. So you can say 100 minus 60. 100 minus 60 is 40. Now, because data is evenly distributed, it means that the 40% you have is catering for this side and this side here. So what does it mean? Since there are two parts that are remaining, you will say 40 divided by 2, which is 20%. That means that this first part here contains 20%. This second part here contains 20%. Now, for you to be able to get the middle 60%, you are going to have from here, this is 0 and this is 20. Then this side, this is 20 plus 60, which is 80 here. So this is going to be 80 and this is going to be 100. That's how. Now, for you to be able to find the middle 60%, it means that I'm going to come, I'll get my percentile of 80%. Then I'll also come, I'll get my percentage of 20. Then I'll say that P of 80 minus P of 20. The answer I get is what we call the middle 60%. In case that asked, let me say let me say 30 or 40%. Let me say 40%. That means that you are going to come and first place your 40% here. After placing 40%, you ask yourself, what is the remaining percentage? It is 100 minus 40, which is 60. But I have the upper, this side, I have the lower. So I must divide them evenly. So I'll divide by 2, which is 30. So this side, I'm going to have 30. This side, I'm going to have what? 30. So that means that on your here, when you are calculating your percentiles, I'll have 0, I'll have 30. Now 30 plus 40, what is it going to give you? It's going to give you 70, and then this is going to be 100. So to get the middle 40%, I'm going to come and say middle 40% is going to be my P of 70 minus P of 30. That's how you get that. Here I've said in case they have told you middle 40 what? Percent. It means you'll get the P70 minus P of 30. That's how you calculate it. So please pay attention to those. When they say middle of this percentage, first put your percentage there. Know what you are remaining with as the balance, and then divide by 2 since there are two distributions, the upper and the lower. So with that, allow me now to calculate it. So allow me to add a page here such that I can calculate that very fast. Very fast. You are going to give me, allow me to calculate that very fast. I'm going to calculate it very fast. Okay. So to calculate that, we are going to come and say, now I'm going to first find the P. Remember, we have said of 80. So that means that your formula, you still use the same formula. Summation L, which is the lower class, 80% of the summation of F minus cumulative frequency before out of frequency of the median class times the class interval. Now, what are you going to do? You are going to first find the 80 over 100 of summation of F. So this is going to be 8 out of 100 times 134. When you make your calculation, 80 divided by 100 times 134, you are going to end up with 107.2. So when you go back, you are going to go to your frequency distribution table and then ask yourself, in my frequency distribution table, where do I have 107.4? You note from our table that it is here. It is the last one. So that means your class interval lower, I'm going to use 59.5. Class width is 15. What else? Cumulative frequency before is 104. So I'm going to come back here in my formula. Hope we are still on the same page. So I'm going to come back here and say this is 59.5, then plus, here we shall have 107.2 minus 104 out of 30 times the class interval, which was, it was 15. So when you make your calculations, you'll get 61.1%. Do the same to the P of what? Of 20. So still we do the same. I'm going to give it to you that one, you are going to do it as your homework just to check. 59. You are going to do it as your homework P of 20, but you'll have 34.5, then plus. This is going to be 20 out of 100 times 134 minus 21 out of 27, then times 10. So here you'll end up with 36.648. But since they told us the middle of the 60%, then we shall subtract the 2 marks we have obtained. So that means you have 61.1 minus 36.648. Then you'll end up with your answers 24.452%. Now you'll make your conclusion basing on that. So that is how you get the middle 60%. Okay. Okay. So I'm going to move on a bit. Now, so that's how you do it. But now I'm going to, I've gone a bit high. I've gone a bit this, but allow me to, I share something. But this is, I know, those who have done GP, in case you have done your general paper very well and analysis, I know your teacher might have looked at this kind of table when you are interpreting your Likert scales. But I want you to borrow your knowledge that you have from your general paper. Now, we have what we call the variations. Now, I'm looking at the interpretation, how we interpret them. Now, when we are looking at percentage variation, like I've said that variation always related to mean. So percentage variation, always we look at the standard deviation, divide by mean, then times 100. Now, when you look at what we obtain for our number, you notice that our standard deviation was 12.9395. I can divide it by our mean, which was 49.388, then times what? 100. So when you divide that, 12.9395 divided by the 49.388 times 100, you notice that your percentage of variation was 26.19968. You are trying to look at what percentage was deviating. So when you look at 26.6, it is here. That means that in case you are commenting about the performance, this is a moderate variation. In case it is about consistency, it is a moderate what? Consistency. So that means that the learner's performance was reasonably consistent. That's how you can comment. But please borrow your knowledge from your general paper when you are looking at data analysis. So that is where you can borrow some knowledge when you are making your conclusion for such. So your conclusion for this, I would say that consistency of learners' performance, the standard deviation is 12.9. Here I'll put that this is percent. This shows that learners' scores are spread by about 12.9 marks from the mean score of 49.3. Therefore, learners' performance is moderately consistent with no extreme evidence of high variation. So like I've told you that your standard deviation, always we compare it to the mean. How your values keep on spreading, scattering from the average score. So this is how you can state your conclusion for such that what is the consistency? 12.9. I've showed you why we use the word moderate. Moderate depends on the percentage and the range where your values lie. So that's how you can make that conclusion for such. So, but here at your level, you can, at the level where you are, please compare your standard deviation with the mean like the way you do for your general paper, or like how you have done in your general paper under analysis, whatever your teacher has taught you during data interpretation. Now, allow me now, because I've seen some of the questions you are asking about these tables. So allow me to throw some light. Allow me to throw some light on these tables. Now, in this particular topic, you are going to meet quite a number of classes. You are going to meet quite a lot of things. But one of the tables you are going to meet tables whereby the class width are equal. How do you check for your class? How do you check that how do you check for that the class width are the same? When you look at these two values here, when you get 19 minus 14, you notice that 19 minus 14 gives you 5, which is your class interval. 15 minus 10 is also 5. Here you get 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 5. Now that is an indicator that your what? Your class width is the same. So here you find that your class width is 5 throughout. Now, when you are dealing with such tables, remember to get the class boundary. To get the class boundary, you need to know what am I subtracting. But I always encourage learners to look at these values. And I told that one that you can call that one an adjustment factor. So you look at 15 minus 14 and then divide by 2. You get the upper and this value. If you want, you could get these two values here. You get 30 minus 29 divided by 5. The answer you get here, whenever you do so, is what you are going to be adding and subtracting on your class boundary. So this will be 10 minus 0.5 to 14 plus 0.5. That's how you can do it. I know you know how to get the class mark, frequency, and cumulative frequency. That's when they equal class width. Now, sometimes you are going to find when there are points. Still, to get your class boundary, you can just, in order for you to get your class width, to check 1.7 minus 1.4. 1.7 minus 1.4. What do you get? That for that one, I'm getting my answer 0.3. When you check the next one here, I want you always to be very careful. When you check 1.5 minus 1.2, you check that here it is also 0.3. When you check 2 minus 1.7, you notice, so you are going to notice that here, your class width are all of them are 0.3. But you ask yourself, how do I obtain the class boundary? Like I've said, get these two values here. You get your 1.5 minus 1.4 divided by 2. What do you get? 1.5 minus 1.4 is 0.1 divided by 2. You'll end up with 0.05. That means that your class here, you're going to add and subtract 0.05. Then the rest are going to remain the same. In case you have such, there are times when you are going to meet unequal class width. Now here, when you check out your class width for such, you need to be very careful. You need to be very careful. 1, on your class width. Number 2, on what we call the class mark. Now for such, when you are obtaining your class boundary, still check these two values here. So that is 25 minus 24 divided by 2. What do you get? You notice that that's 25 minus 24 divided by 2, 0.5. So that means that here you are going to have 19.5 to 24.5. 24.5 to 29.5. Now, this one here, dear students, where you have one value, still you do the same. Add and subtract your 0.5. So here you write your 29.5. Upper will be 30.5. Then you continue 30.5 to 34.5, 34.5 to 40.5. Now, when it comes to the class mark, please and please, here you can consider the class boundary. Remember, when you are getting the class mark, you can get the upper class boundary and this. So you can say, if you want, I know some of us are used to these ones, so you get 24 plus 20 divided by 2. So here your class mark is going to be 24 plus 20 divided by 2, so you put your 22. Then 25 plus 29 divided by 2, you put your 27. Now for this one here, never make a mistake for you to put that it is 15. So here you put it the way it is. It is what? That. That's why I'm saying that alternatively, when you are getting your class mark, as long as you add your class boundaries and divide by 2, that is very good. But this is what I wanted you to pay attention to. When you meet such values, then another format you can find is this. Sometimes you can find your class limits whereby these two values adjacent to each other are the same. Now, for such cases, when you get your adjustment factor, you notice that 15 minus 15 divided by what? 2 is 0 out of 2, which is 0. Now, whenever your adjustment factor is 0, that one, you don't need to do anything on the class boundary. Put them the way they are. So here your class boundary will remain the same. 15 to 20, 20 to 25, 25 to 30, 30 to 35. As long as these two values are the same, the adjustment factor, then that one remains the same. So I know you now find the class width and other values. Now, there are times when you are going to find inequalities. Still, for inequalities, please do the same. Check out the inequality. Check out yourself. Sometimes these inequalities are going to have the same class width. When you check here, this is 10. When you check here, it is 10. When you check here, it is 10. Here, it is also what? 10. Now, when you are getting the class boundary, look at the adjustment factor. 20 and 20. It means when you say 20 minus 20 divided by 2, you get 0. Now, here your class bounded as 10 to 20, 20 to 30, 30 to 40, 40 to 50, and the rest of that. So that one, you need to be very careful with that. Still, when it comes to class width, please don't forget, you have to say 10 plus 20 divided by 2. 30 plus 40, then divide by 2. Now, when it comes to classes, we have open classes that you are going to find like this. Now, for this one, I always encourage that start from down. Because when you look here, 30 minus 20, your class width here is going 30 minus 20, 40 minus this, this minus this. You notice that here your class width is the same. So here you'll find that your class width is going to be what? 10, 10, 10, 10, and 10. Now for such, this value here, when you are getting your what? Your class boundary comes. So you say this is 50 to 60. This one comes here, 40 to 50. This one comes here. This is going to be 30 to 40. This one comes here. It's going to be now here. It's going to be 20 to 40. Now you notice that the class interval was the same. Now here you have to be very careful that here your value is going to be 20. But for us to maintain an equal class width, here now we shall have 10, such that the class width is maintained as 10. But there are cases where that you need to be very careful. In case it was this size, you notice still the class width is the same. But here now, class boundary will be from 0 to 10, such that we maintain the class interval as 10. Okay. Another case you are going to meet is going to be this. When you look at the class interval here, you notice that the class interval are differing. When you look at this and this, it is here, it's going to be 40 minus 20. When you say 40 minus 20, this is 20. When you look at the next one, 45 minus 40, the class interval is what? 5. The next one, 60 and 45, you notice that the class interval is 15. So you notice that the class interval is different. What do you need to do now? For here, like I've said, once you meet such open classes, start from down. 60 comes here. So you say 60 to 95. Bring your 45 here. So you say this is 45 to 60. Bring the 40 here. This is going to be 40 to 45. Bring the 20 here. This is going to be 20 to 40. Now, the next one here is going to be 20. Now, whenever you find that the class interval is different for all, then here always start from 0 for your lower class. Always start from 0 for your lower class. Then the rest are going to remain the same. But here now, please take note. In case I'm getting the class width, please, now here it's going to be 10. 0 plus 20 divided by 2. 20 plus 40 divided by 2. Now here I don't 20 plus 40 divided by what? By 2. So you need to take into consideration that as you find a class width. Okay, you are going to find classes of this nature. Now, in case you find a class of this nature, first check out what is the class interval. 60 and 50 is 10. 50 and 40 is 10. 40 and this is 10. This and this is 10. Now, the moment you find that it is the same, then it is okay. What do you need to know? That now for this, I'm going to say 20 to 30, 30 to 40, 40 to 50, 50 to 60. Then this is going to be 60. Since the class width is the same throughout, then this one will become what? 70. Now, when it comes to class to here, everything is what? Is 10. When it comes to the class mark, then it means you have get this class boundaries 20 plus 30 divided by 2. 30 plus 40 divided by what? By 2. And then go on and find the other areas. So you are going to find classes of this nature whereby the class width is different for each. When you check here 35 and 20, you notice that 35 and 20, here it is 15. When you check 40 and 35, you find it is 5. 55 and 40, you find it is what? 15. You notice that the class width are totally different. Now, for such, you'll start 20 to 35, 35 to 40, 40 to 55, 55 to 70. Now, whenever you find that the class width is totally different for such open classes, then what are you going to do? For the last one, you're going to say 70 and leave an open boundary here. Leave an open what? Boundary. Here, calculate your class width. Calculate your class mark. Class mark. For the last one, leave a space because you don't know what the upper boundary is. Now, other things they can use, sometimes they are going to use words. They are going to use words. Which words are they going to use? They are going to use words such as under, above, such words. So they will tell you that below 10, then they write for you 10 and under 20. Now, those ones don't get scared. 20 and under 20. That's how you are going to write them. Under are this. Sometimes they can say up to, above and up to. Such words. All those are different techniques that you need to know when you are attempting such item whenever it comes to what? Classes. Now, those are the different ways how they can ask you when you are looking out for this particular data. So I think I've exhausted all the possible ways they can now give you this particular data. Now, there are times when they are going to just give you data and you have to form your own classes. They are going to give you data. Let me say 15, 20, 25, 30, 40, 45, 60, 75, 80, 85, 90, 95, maybe 30, 40, 50, 20, 10, like that. Now, once you find that your data has been given like this, and they want you to form to form your classes and do the data, what do you do? Now, I want you to know that the convenient values, class width that you can use, the convenient ones are always 5 and 10. Now, when it comes to such a case, first identify what is my highest value in that data set. It is 95. So what are you going to do? You are going to come and get your highest value minus the lowest value. For this case, it's going to be 95 minus the lowest value for our data here, which is what? 10. Now, you first test. If I'm to use 5, how many classes will I have? So when you say 95 minus 10 divided by 5, you get 17 classes. These are very many classes. When you say, in case now you decide to use 10, you will say 95 minus 10 divided by 10. So 95 minus 10 divided by 10, this is 8.5. These are about 9 classes that you are going to form. Now here you make a decision. I want to let you know that whenever you are forming your own classes that are between 5 and 10 are very beautiful classes. continue with them. But anything above 10, above 12 is very big. Anything below 4, it is also going to be very poor. Why? Whenever your classes are very big, your values, your data is going to spread out. Your measures of central tendencies are going to spread out widely. So whenever you have class intervals, your levels of accuracy are very, very high. Now for such, now you know that now the best class interval to use is what? 10. Now what do? Come in your data, check out for the lowest value is 10. So start from 10 and say now this is going to go to 19, 20, to maybe 20. This is what? 20 what? 29, something like that. And then your things are going to be flowing. That's how you can form your own classes. When you have just been given the data and they want you to do the tallying. So I want to bring that one to your attention. Now, I think when I look through the chart, unless people are saying we can first complete this item, or we stop here, kindly let me know through the chat. Should we stop here or we first complete this normal distribution? You can let me know through the chat. Okay. Okay. People are saying we continue. Okay, we continue and we... Okay, people are saying we first complete at least this item. Now, when you look at this second item, at the second part, it is about normal distribution. When you are approaching normal distribution, I want you always to define the variables you are going to use. When you read through it and you look at our answers, when you look at the standard deviation they have given you here, you can, if those who can relate very well, the standard deviation we got in the first part is similar to what we have here. Sometime they will even tell you, sometime they are going even to tell you to use the above values you have used for standard deviation and the rate to calculate or to make calculations here. So I want you always to first define what you are going to use, that let your x be approximated or to the max of learners. Then from there, you say now x is approximated to a normal distribution with the mu and variance. Then you can come and say, now x is approximated to normal distribution. Your mean is 48.6. What is your what? Your variance is going to be 12.9 squared. Now, what does the district want? The district assessment policy want the score between 50 and what? 60. So you are going now to come and say now the probability of students who scored between 50. Now here to look at the round rate between. So it means you are going to say 50 less than your value of x less than 60. And now you are going to start your standardizing. So I will say this is P 50 minus my mean, which is 48.6, divided by standard deviation, less than the z value, less than 60, minus the 48.6, everything divided by 12.9. Now here, we are going to have our 0.1. Now remember, when you are going to use your tables, you write to only 3 decimal places. So this is going to be 109, less than z, less than 0.8, 80. Oh, is it 884? Yes, I think it is 884. That's what you are going to have. Standardize your values. Now, always have that small sketch to show that you understand what you are working on. So I'm going to come and now, and please take note, because our standard tables, when you look at the UNEP tables, they stop somewhere. So I'm going to come here, I standardize, I know this is my mean, and then I plot very well that this is my z value. This is like where I have 0.109. This is where I have 0.8884. So from there, allow me to come to my tables. But here, please you take note that in order for you to be able to find the probability of this, you have to get the z value of this minus this. So this is the same as having 0 less than z, less than 0.884 minus probability of 0 less than z less than 0.109. So you go to your table, you read out 0.884. So when we come to our table, 0.8 is here. When I look at 8 where 8 is somewhere here, so that is 0.3106. And when I look at 4 is here. So I'm going to add 0.0011. I add. So our value here is going to be 7113.0. When I look at the other value, so when I go back here when I go back here, it's going to be 0.3117 minus 0.109. When I come to our table, we are looking at 0.109. 0.1 is here. I'll move in this row here. I look for 9. 9 is here, which is 0.0753. Hey, sorry. I'm looking at 0.1. Fact, this one I'm not sure. 0.1 is here. 0 is here. So it's going to be 0.0398. Then I look out for 9. 9 is here. So when you check out very well, 9 is here, which is 36. I'll have 0.0036. So then I add my probabilities. I'll have 8 plus 6, which is 14. 9 plus 3 plus 1, which is 13. Then this is going to be 4, 0.0. So now I'll come here. Where? Okay. Let me come here. I have no problem. I'll have now my probability of 0 less than z less than 0.88. 4 minus my probability of 0 less than z less than 0.109. And here we got our answers 117 minus 0.0434. And remember, when you're writing probabilities, we write them to 3 decimal places. Now, this is going to be our probability. But when you go back to the scenario wanted you to the assessment. Wait, from here, the district has budgeted learning materials for only 95 what? Learners. So, but you ask yourself, how many learners? What was the sample? When you look here at the sample, in the current year, 500 learners sat the mathematics assessment. So to be able to estimate the number of learners, you are going to come and say estimated number of learners. Estimated number of learners. Remember, we stick always to the language. We say is equal to n times p. So now our number is 500 times the probability, which is 2683. And when you get this, you notice you have 134.15. So this is approximately 134 learners, because we can't have 0.15 learners. So now you are going to come and say that compared to how many learners scored between the what? The 50 and then the 60. So it means that there are 134 learners. Now, what are you going to do? You are going to go back. And then make a conclusion, make a decision, and interpret based on the answer you have got. From what the district is planning, they are planned for 95 learners. So you are going to say that the available learning materials are not likely to be enough. I want you now to remember the language to use. Remember, I think your teachers, when they were handling probability, they showed you what we call a probability scale. That if you get your probability, when you look at our probability, is 0.2, which is very below when you look at the probability scale. So that's why I'm using the word because likely, those are probabilities. So we are saying that the probability is unlikely. That's what we call unlikely. So we shall say that the available learning materials are not likely to be sufficient. Why? Because the the estimated number of 134 is bigger than the 95 learners the district had budgeted for. So what is going to happen? It means that it's not going to, what does it mean? It means that now the district needs to plan better. They need maybe to add in more assessment, maybe to add on more books or to add on more learning materials. So now that is how you can conclude for that particular part. So that is what I can add on for now when it comes to that. So I hope you have understood, and maybe the last bit I can talk about before we leave this number is that please, I want you to understand that under descriptive statistics, we have basically three major central tendencies: mean, mode, and median. And whenever you make your calculation, you'll find that the answers you have got, and we have what called measures of dispersion or what called variability. And those ones, we have what called the range, we have what called standard deviation, quartile deviation, and what we call the variance. Now, when they talk about quartile deviation, please don't get in upper minus lower quartile, then you divide by 2. So sometimes they can use quartile deviation, let it not confuse you. Their deviation. Then you know how to deal with the variance. Then we have what called measures of frequency distribution. Whenever we are looking at how frequencies are distributed, then there we are looking once. We shall look at what we call the box. There's another distribution called the box. Here we can also look at pie chart. That one shows how frequency is distributed. So next time they may not bring for you histogram, that you draw histogram. They can ask you that, show graphically how frequencies are distributed. Now there they are asking you to use a histogram. So you need now to know the language. If they ask you the measure of dispersion, then you need to know, depending on the data, that the best one out first start with is the standard deviation. And once they use the standard deviation, sometimes they will ask you to first calculate the mean, such that now you can be able to make a conclusion based on the results you have obtained from the mean with the standard deviation. Now that's how. So that's the kind of what? Scenarios. So why don't you allow me to first respond to only 3 questions? I'm not going to exceed 3 questions. The first question, home PC, you may ask. Lutete Secondary School, unmute and ask. Chikoni Integrated, unmute and ask. And maybe Geoffrey Insgoma. Okay. Oh, now Namugongo, ask any of you. I want to respond to a few questions. Yes.
They are confusing.
Yeah, good evening.
They are confusing.
You want?
Good evening.
Yes, good evening.
I'm requesting you to help me to remind me about the expected number of learners.
The expected number of what?
Learners.
The expected number of learners.
Expected number
Always
of
get
learners.
the number times the probability. Is that fine?
Remind me.
You get the number, you get N is the number, the district sampled, which was 500 times the probability, because they are expecting to distribute, they have 500 learners, and the probability for someone to have scored between 50 and 60 is this. So get the number of learners times the probability, and then compare with what the district had planned for. Okay. Okay, Namgonga, I have muted you. Kikoni, Chikone?
That is
Okay, is Goma, I've also muted you. Okay. Matia Mulumba? Yes?
Yeah, I would like to know.
You want to know how?
What if we find that the given mean
You
is greater
you are not clear. What if? Okay. I think I've also failed to get you. Okay. I think I'm failing to get people. Matia Mulumba? Okay. I think I'm failing to get some of you, but allow me to use the chat to check out whether there is any burning question from the chat. Okay. So we are going to end at this point. What's meant by dominant mark? They are indirectly asking you for mode. Dominant mark, commonest mark, and the rest, that is mode. Okay, now. People are asking, members, let me know through the chat. Do you want us to first finish mechanics? Let me know through the chat whether you want me to first finish mechan and then we complete. Let me know through the chat whether we can first complete mechan. I'm waiting in the chat whether members want us to first complete mechan. Okay. I think the responses in the chat are saying that yes. Okay, members are saying we first complete mechan. Okay, I have no problem. Okay. Let me complete mechan. Let me complete mechan. Okay, now when it comes to dynamics, it has basically three things that you need to know. That when it comes to dynamics, dear students, this is our item that we are working on. But like I've said that always, I want you to check out that scenario that has been given to you. That scenario that has been given to you, life, related to real life. When you look at this scenario and you internalize it very well, in real life, you have seen some of these things happening. You have seen a car pulling each other. You have seen such things happening. Even at home, some of you with your bikes, you keep pulling people. Now, this is the real life situation. When you look at that scenario of mechanics, this is what it was looking at. But before you pull your friend, even at school, before you pull your friend, please first ensure that your muscle is big enough to pull the person. That is what mechanics was looking out for. They were looking at two cars. And here, please, when they talk about a trailer are those bodies behind. They don't look at that whole car as a trailer. We are looking at something following. So a trailer is that big thing that carries the other. Now, this is what we are going to look at in real life. I've showed you the real life aspect of it, that in real life, this is what it looks like. Now, when it comes to mechanics, I want you always to indicate the forces clearly. Show the forces, show the frictional force when it is there. Resolve perfectly well the way the scenario is. Now, they told us that Uganda National Roads Authority, they are testing a towing vehicle that will be used to transport construction materials to a road project located on the steep hillside. But before the towing system is deployed, engineers must verify whether it can fully pull the trailer up to the access load. When you look at those trailers, when they are very big ones, you always see that there is maybe a metallic thing. Sometimes there may be a rope, maybe something like that. Now, before they put it there, they always first check out what is the maximum load, what is the tension, what is the force that this particular thing can move. Now, when you check out on our diagram we have here, now we are going to go on and make a sketch. Whenever they give you diagrams here, please ensure that you make a sketch again. And when you are indicating those forces, don't leave the things in the paper. Please indicate the forces very well and move with it in your paper. Draw again the diagram. Show clearly all the forces. So now we are going to show all the forces acting on this. So when you look at my diagram here, I'm going to first come that they have given me the angle theta. But from the item, they told you, they gave us sine of theta. And they told us that sine of theta was given by, I think they gave us sine, was given by adjacent. This was, the sine was 7, I think, out of 25. Allow me to just be sure from the scenario what they gave you. Yes, it was 7 out of 25. Now, the moment you find that they have given you such, I always encourage you that they want your levels of accuracy to be very high. Never go on and find theta. Now come, first make a simple sketch. You know very well from your SOHCAHTOA that is opposite theta there. You know your opposite is going to be 7, hypotenuse is going to be 25. Now, find what your adjacent is. What is your adjacent? 25 squared minus 7 squared. But everything is going to be under root. So you can, if you want, you can put here x, and then you know that x is that. But here, we are using Pythagoras what? Theorem. So when you get 25 squared minus 7 squared, and you get the square root, you'll get your answer as 24. So for this particular one, here on our adjacent, we have 24. Now, put the forces there. You know that whenever something is at rest, what happens? Oh, there is no more reaction. So we are going to first put our forces. So our first force we are going to put here on our diagram, we are going to say that we shall have here on the trailer. We are going to come here and say now this is our reaction force. Now on our reaction, I want you to know how does weight act? That we are going to come here and we know that this is going to be our weight. And you remember that weight is always given by mass times gravity. What is our mass? Our mass is 600 kilograms. What is our gravity? Allow me to first use G as our gravity. So our weight here is going to be 600 G but newtons. The same thing is going to come here on the car. I'm going to indicate that this is my reaction. I'm going to first indicate what is my weight. And please show these calculations. I know you know a lot of math and you want to skip steps. Times G. So come here and indicate that this is your weight, which is 500 G. Now, what are you going to do? You are going now to start resolving. Acting on this particular on this particular one. So we have to calculate. This is also our weight. We are going to come and find our weight when we have resolved it. The same thing is going to happen here. We are going to resolve, and also we are going to resolve such that we get the vertical component and the horizontal component. But you know, I know you have done connected particles, that the angle you have here is the same angle you have here. So this is also theta. Also the angle you have here is the same, which is theta. Now, when we are resolving, I want to just make a simple sketch here that when I'm resolving, this is what I have. That this is my angle theta. Now, here you have your weight. For the first diagram here is 600 G. what are you looking for? You are looking for which is y, this is my horizontal, which is x. Now, if I'm to resolve this angle, I have to resolve it vertically like this. But if this is my right angle triangle, this side is my opposite, and this is my adjacent. Now, in case I want to get my y, I'm going to use adjacent and opposite. So that one is going to be what? Sorry, I'm going to use, I have opposite, I have adjacent, and this is my hypotenuse. So when I decide to use cos of theta, cos is always given by adjacent out of hypotenuse. So mean that my cos theta is going to which is y divided by adjacent, which is 600g. So what is my y? When you cross multiply, you'll have 600g cos of theta. Now, that's why when you resolve horizontally here, we shall have 600g cos of theta. What about horizontally? Since it is opposite and hypotenuse, it means that I'm going to say sine of theta is equal to opposite, which is my x, out of hypotenuse, which is 600g. So when you cross multiply, you'll have 600g sine of theta. So here we shall have 600g sine of theta. You are resolving. Still, similarly, here we shall have the same 1500g sine of theta, and vertically here we shall have 1500g cos of theta. Those are the forces that we have. Now, after knowing, now that I have resolved my forces vertically and horizontally, read the scenario again. Read the scenario again. They told us that this particular car we are dealing with had a driving force. That this car had a force of 8,400 newtons. But the car and the trailer were being resisted. There was friction force. Okay, sorry, I think I'm back. I'm back. I went off. Okay, now this particular thing had a driving force. And what was our driving force? Our driving force was 8,004. So I'll put here that this is 8,400 what? Newtons. But it had also resistance. So when you are indicating resistance, resistance acts on the ground. So we shall put here that it had resistance here. I put it on ground here, that this is the ground. And what did it have? The car had 400 newtons. Then this trailer had which resistance? It had 300 what? Newtons. Yeah. Now, that is my diagram that I've finished to resolve. And now I'm going to start. I'm going to start now unpacking all the forces acting on the diagram. Now, what am I going to start with? I'm going to start with the trailer. I'm going to say, remember, I told you must communicate. So I'm going to start with forces acting on the trailer. When you look at this trailer, I want you to take note which forces. In fact, now I have to put that in this string here, we have what we call the tensional force. Dear students, whenever it is one string, or whenever it's one tau, always the tension is the same. But if the strings are different, tension is different. So you can have T1 and T2. But since this is 1, then we are going to have only one tension. Now, I'm going to say forces on the trailer. So I'm going to come here and I say forces acting on the trailer. So you are going to allow me that now I make a simple sketch such that now I make it very clear here that here for the trailer, you had the 300 Newton. The trailer here, you had your 600 G cos of theta. The trailer here, you had your, here, you have the tension force. You have the tension here. Now, remember, dear students, that this car is being pulled. So acceleration due to gravity is in this what? In this particular direction. Because it is being pulled along the what? The hill. They are trying to test it. So here now I'm going to come and say, this is my simple sketch. I've just pulled out that this is my acceleration, that this is the direction. So you know very well that force is always given by mass times acceleration. Now for this particular trailer, you are going to ask yourself, what is the force driving? That T, since it is going this direction, T is bigger. So I'll say it is T minus, which forces are opposing? You have the 600 G cos of theta, then plus the resistance, which is 300, should equal to the mass, which is which is 600, and then times acceleration, which is A. And this is your first equation. When you come, you are going to look at the next vehicle, which was the car. The car had its driving force, which was 8400. But this car was also being resisted by 400 Newton. But this car still had its force resolved, and we had 1500 G sine of theta. But still this car here, we had our tensional force. Now, when you look at this car, it is moving this side, and this is the acceleration. So the force, still we shall say force is mass times acceleration. So which forces are acting? The driving force is 8,400 minus the forces, the 400 that is resisting, plus the 1500 G sine of theta, then plus the tensional force. Because all those ones are resisting, will equal to the mass, which was 1500, then times the acceleration. This is your second equation. Now, these two equations you have formed are the ones that are going to support you to obtain your acceleration and to obtain your tension. So what are you going to do? You remember very well, like the diagram I have demonstrated, that in that diagram, you had 7, you had 24, and you had 25, and this is where theta is. Now, where there is cos theta, I'm going to just come here. So I'm going to come and say this is T minus 600. Now, we always look at your question paper. So your question paper, you'll find that your G has been given. So look there. So here we are going to use G as 9.8 meters. So here we shall have 600 times 9.8 times what is cos theta come here. Cos is given by adjacent out of hypotenuse. This is going to be 24 out of 25 plus 300 is equal to 600A. So now we shall have our T minus, when you put this in your calc and you make your calculation, I'm getting 1946.4 is equal to 600A. This is another equation. Do the same here. This is 8400 minus 400 plus 150 times the 9.8 times sine theta come here. Sine is opposite out of hypotenuse, then plus your T is equal to 1500A. So when you simplify, this is 840 minus. This is going to be 4116 plus T is equal to 1500A. So when you try to simplify, this is 3884 minus T is equal to 1500A. Now this is another equation. Now your task, dear students, is to solve this equation and this equation to get your value of A. So what I can do for here, I can make T the subject, so I will get 600A plus 1946.4. So when you substitute here, you'll have 3884 minus 600A minus 1946.4 is equal to 1500A. So from my calculations here, I'm getting my A as 0.92267 meters per second squared. Now, after obtaining your A, you are going to go on and obtain what your T is. So T, substitute in any of these equations. So you can come and say, my T now is going to be 600A plus 1946.4. So substitute, this is 600 times the 0.92267, then plus 1946.4. So when you make your calculations there, 600 times 0.92267, then plus 1946.4, you get your answers 2500.002 newtons as your tension. Now, after obtaining your values, you have obtained your tension and acceleration. Go back to the item. What did the item want you to do? That my item wanted me to check whether the tension, whether the towing vehicle accelerates at not less than 0.9. Now, when you check the answer you have obtained, you are noticing that the answer we have obtained for acceleration is this. What does it mean? Now, you are going to first make your first conclusion that the towing vehicle is at now here you need to take note that it's here you need to understand they're asking you that whether the vehicle accelerates at not less than 0.9. So when you check our value, this is our value we have obtained, and this is the value they want us to compare to. So now there you make your conclusion that the towing vehicle is accelerating at 0.922, which is above the 0.9 thing. So the value is not less than that. It is instead above that. When you look at the tension we have obtained, our tension we have obtained is 2500 point something. Now, the tension in the tower does not exceed this. So when you look at our tension is less than 26. So you are going to make a second conclusion that the tension in the top bar does not exceed 2600. Why? Because 2500 is less than 2600. Now, those are your conclusions. Now, you are going to make recommendations. That what recommendations are you making? That since the acceleration and the tension fulfills the proposal or fulfills the thing, therefore, the executive director or the project engineer or whatever, they should go on and approve the system for use at the constructional site. So that's how you deal with that particular particle. Okay, can I take on some hands? Now I'm seeing very many hands, but I know there are those that had left their hands up. St. John, allow me to take only two. St. John, ask. Yes, St. John. Okay, I'll fail to get St. John. Kitatia SS Kayunga, ask.
Okay, thank you, sir. Back to item 2 for the 36. Is it that the part 2, item 2? For the equal intervals, does the formula for mode, like for unequal intervals, does the formula for mode and median change?
No, those formulas remain the same.
Okay, thank you, sir.
Okay. Okay. Malacha SS, Okandego SS, Light Vocation, Kolil Comprehensive, Kinoni High, Kigalama
Yes, sir.
SS. Yes, please go on.
Secondary school.
On the
Light bucket.
yes, Light Vocation, go on.
They don't like they don't affect.
Yes,
About this one.
Light Vocation, go on.
I'm saying,
Hmm.
why handling trailer instead of saying sin theta, use cos theta.
Why here?
Instead of sin theta equation 1, you have placed there cos theta.
Let me go back. I need to check. Oh, this is supposed to be sine. Oh, okay. I'm saying this was supposed to be sine. This is sine. This is sine. So this one is going to be. This is going to be 7 out of 25. Thank you. But the answer will remain the same. Okay. Thank you. I think it was a writing error, but on the diagram was clear. Thank you. Okay. I think the rest you can make that thing. So here it was supposed to be sine theta, and then you substitute accordingly. Okay. In case they had asked for the reaction, then I would expect that for your reaction, you'll go back here and say the reaction now is going to be 600 G cos of theta. Then you substitute, well, you say 600 times 9.8 times cos theta. You come here, you say cos is what? Adjacent. Yes, adjacent out of what? Hypotenuse. Then you get the reaction force acting on the vehicle. Okay, allow me to just check and see whether. Oh, thank you, Malacha. Okay, I've seen the sign. Okay, for sign. Okay. Okay, but the calculation, everything remains the same. Okay, Hannah, you have a question? Anna, ask.
Yes.
Okay.
Yes. Yeah. Thank you very much. I just wanted to know. I don't know why. That meters cannot be changed to. Can be changed to.
Why? Oh, I think you are using very many devices.
That force that is acting on the trailer.
Why?
There is a force that is acting on the trailer. So I'm not understanding where it came from. Like
which force?
Like, that 800. I think 8,400 is acting on a car. But I'm seeing you put it on the trailer.
This is the car.
Yeah.
Yes.
So
remember, this is the car that is driving the trailer. The trailer is like the body. That yes. But the thing where they put goods is what we call the trailer. But what
Yeah.
is driving is the car in front.
Okay.
Thank you.
Thank you.
Okay. Okay. Allow me that we are going to end here. I know you have quite a number of questions, but can you first have your videos on? And at least let me, I look at how your classes are. Okay. Thank you so much, dear students. I'm happy to see all of you. We are going to have Math 1 next week. We shall have Math 1 next week at the same time. And I will ask teachers, can you first take some photos of your students? I'm really very happy. I want to keep those pictures such that next year as we celebrate the performance, we can be able to get those pictures. But thank you so much. I'm very happy and proud of all of you that have been able to make it. I know next week we shall be able to complete to do paper 1. In case of anything, alert me early. But next week, I think as you are coming, you will tell the kitchen staff to keep for you your meal such that you can come, because I think also it may stretch a bit, but we shall try to summarize. But most importantly, I want you to understand the concept. Thank you so much, everyone. Thank you so much, all the teachers that have been able to connect the children. I wish you all the best, everyone. I'll see you tomorrow. I think next week we shall as well have Math 1, GP, and others. Thank you, Okwanga SS. I'm seeing Water Bright, Ndechie, Isigoma, Ikumba, Paulo Rita, RH, Blembe. Yes, George Insigoma, Stephen, Collins Truth. Yeah, I'm very happy. I'm very happy to see all of you. Yes. Thank you and have a lovely evening. See you again tomorrow for another session. Let's keep practicing the math. Keep practicing. And we shall continue to share with you more items to try out, such that at least you can be able to strengthen your muscles of math. Thank you, and let me wish you good supper. I think you are going for supper. Some of you have missed supper, but it is worth it. So let me wish you all the best. Bye. Yes.
That one's okay. You're not going to come.
You want to come here?
Oh, yeah, sure. Hi. Hi guys. Success to all of you as you go for more. All the best. Who are you? Who are you?